we spent more than 2 hours on optimization problems, which is section 3.7. Now, I'm not sure you finish all the homework, but the way you check whether you understand the subject is you randomly pick up the homework problems. Are you able to quickly, write down the function to find the minimum value or maximum value for the problem? Okay. If you have to come to my office, take the makeup quiz. Those quiz problems are different from homework problems. Of course, they're just modifying of the homework problems. Okay. For example, the homework problem is for making a box, and a similar problem, I just say leave the top open, given the surface area to find the maximum volume you can get. Okay. But if you understand the idea, then you should be able to solve it. Okay. So we have to move on. Okay. And we try to learn how to evaluate the integrals. Okay. So we begin with the so-called antiderivative function. This is an inverse problem. Okay. Antiderivative function. Section 3.9. All right, so let's give a definition. So if this is definition. So if you have a function, the derivative of that function is equal to little fx. Okay, then this capital Fx is called an antiderivative of little fx. Okay, this is an inverse problem. We want, given a function, we want to find the derivative. But sometimes, given function, we will ask you what is the function whose derivative is equal to the given one, right? And before we solve the problem, we needed to know the following fact: how many antiderivative you can get for the given function little fx, and how to describe other solutions. Well, we make a simple observation. So if f prime x equals f prime 2x equals little fx, what's the relationship between f1 and f2? Well, because f1 and f2, they have the common derivative. So the difference, right? The difference, the derivative is going to be 0. Because the first derivative minus second derivative, they're both equal to f, little f of x, so it's going to be 0. So if it's 0, then they are differed by a constant, okay? Constant. Okay. So that means for a given little function, the given function little f of x, if we find the one antiderivative, you can get all, just add a constant. That differ by constant. So there's no need to list all of them. Okay. So my conclusion is, let's write on the general formula, right? If my conclusion is, if you know one antiderivative function, you can get all of them. Okay. So if I ask you to find the general antiderivative of the function, that means find the general formula for the antiderivative of the function. You just need to find the 1 and plus constant. Okay. Let's look at the following problem. We know that the derivative of x to the a plus 1. Okay. When you differentiate this, it's going to be a plus 1 and x to the a plus 1 minus 1, just a. Okay. So let's assume that a is not going to be, assuming that a plus 1 is not going to be 0. Okay. Otherwise, it's just derivative of x to 0 is 0, right? Then you will see that the derivative of it's going to be x to the a, right? Derivative of this function, divide both sides by a plus 1, because a plus 1 is not going to be 0. So what does that mean? That means we find the entire derivative of x to the power a. So the general formula for the entire derivative, so the general entire derivative of this function is given by capital F of x, and which is this one plus constant. So you get all of them. Okay, so that's the answer. Okay. So the entire derivative, you have to increase the power, but meanwhile you have to modify the coefficient. Okay, so coefficient. And you can check that if you differentiate, a plus 1 is gone, right? Then you get answers. Okay. So this is a very useful formula. For example, if f of x is the square of x, find an entire derivative of the function. I'm going to simplify this just AD, okay? Otherwise, that's too much work. So yeah, so find the entire derivative of the function. Okay, so you want to find the function whose derivative is square of x, right? But then if you write the function in the form like this, so in this case, a is going to be 1/2. So the entire derivative is going to be x to the 1/2 plus 1 here, and x 1/2 plus 1. So you simplify, you will get 3/2 here denominator, here 3/2, and after you simplify, you get this. Okay. Now don't forget plus constant if you ask it to find a general formula. If you otherwise just the entire derivative, well, you don't need to put a constant here. So you read the question carefully. If you ask to find the general antiderivative, means the general formula for the antiderivatives of the function, then you have to add a constant c. Okay, otherwise just constant here. Just don't need to put the constant there. Okay, so you can also now you were wondering what happens if here's a question: if f(x) is going to be x to the -1, which is 1 of x, are we able to find the entire derivative? Right? Later on we can find out, but right now we are not able to. Okay, this is a mystery, right? What is the antiderivative? What is in the general formula for antiderivative? Okay. Of this function. Right? Now, if you cannot find the elementary function to describe it, then you introduce a new function. Okay, so in the history, okay, this is fine. See, we already defined the antiderivative of x to some power, right? A plus 1, a, right? But a is not going to be -1. We assume that, otherwise we have trouble. A is not going to be -1. So then it's very curious. See, being a scientist, when you see something like that, then what happens when a equals? You automatically will ask this question, okay? What happens when a equals -1, right? Then you try, up to now, right now, you learn these things, like you know how to find derivative, sine, cosine, but you don't remember anything gives you the derivative x to the -1, right? But I know there is I know there is a power function, right? I know there is an antiderivative function. Okay. Okay, definitely. Okay, we call the fx, capital Fx. The capital Fx is the same as the derivative is 1 of x, right? So what is that? That's, you know, and you can also assume that f of 0 equals 1. The reason is otherwise just add a constant to that, you know, right? You have a family. You can make it to have the values 1. Okay. No, add 1. Okay. You cannot put a 0 there. That's my mistake. Yeah. F of 1 equals 0. Why? You know, he's laughing, right? Because the function is not defined as 0. Okay, but it's defined nearby 1. So you can assume that f of 0 is 0. F of 1 is 0. So such function, if you still cannot find out from the textbook, you know, with this property, and you can name it. Let's just give a name of this function. Okay, you can say I'm going to use 2 letters or 3 letters. Name it. If we cannot use a single letter, right? You can use the name of your cat to call this function. You know, yeah. So then you describe this function and try to understand the behavior of the function. Then later on you create a brand new function. You can, okay, and it shows up everywhere. So definitely this is an important function. It will show up in yeah, because the derivative is 1 of x, so special. So definitely this is a very good function. We're going to use it, okay? And I will tell you this function is actually natural log of x. And when I write down natural log, I say, oh, I heard about that, natural log, okay? And I'm not sure you learned that in high school, but the pre-calculus probably already studied natural log, yeah, okay? The inverse function, yeah. Exponential natural log function. But I'm not going to discuss this later. In 166, there was a section about this, right? But how can we find a little bit more general antiderivative is a little bit more general function, okay, like a combination of 2 power functions. So we need the following facts, okay? It's simple. So if f prime, if this is going to be this, and okay, then you just add them together, okay? Then you add them together, f1 plus f2. This can be f1 plus f2, the sum of this. So you can put the constant here in the b and the b, okay? And then this is true, the sum. So what that means, if we find antiderivative of f1, f2, and add them together, use the same combination, you can find an antiderivative of the combination of these 2 functions, okay? So in other words, if capital, yeah, f1 is antiderivative of little f1, and if capital F of 2 is antiderivative of little f2, then you can easily find the antiderivative combination of those 2 functions, okay? So yeah, in other words, yeah, if f I is an antiderivative of little fi, okay, I is 1, 2, then the same linear combination is an antiderivative of a little f1, b f of 2, okay? So this will be useful, okay, to solve the following problem. Find an antiderivative of the function f of x, which is combination of this, like polynomials. For example, x plus 2x cubed, right? And there's 2 terms here. So the idea is you find antiderivative for each of them. Use the same combination, you can get antiderivative of this function. So first of all, x, this is f1, right? Then the antiderivative is going to be half of x squared. Okay, you find the one of them. Then f of 2x is going to be x cubed. So the antiderivative is going to be 1 over 3 plus 1 x to the 3 plus 1, which is 1/4 x to the 4th power. So in order to find the antiderivative for f is going to be f1 plus 2f2, right? Okay, so the antiderivative of this f use the same combination. Okay. F1 plus f2. Okay, so in other words, capital F of x is the first one plus twice of the second one. Okay, so this is the antiderivative of the function. Okay, so if you can do it quickly, you can just do one by one. You know, you don't need to write in this complicated way. Okay, for example, if f of x is going to be x squared plus 1 over x squared, right? Find the antiderivative of this function. Antiderivative of this f of x. Okay, how to do that? You just find the one by one, right? So capital Fx, 1 of x squared can be written as x to the -2. So this will be 1 over 2 plus 1 plus -2 plus 1 x to the -2 plus 1. That's the first step. Then you simplify it. Okay. Okay, so cube 1 minus 4x. Okay. Find an antiderivative of this little fx. Now this is a product of two functions. We do not have a product rule for finding antiderivative, which means, you know, you can find the antiderivative x cubed, and you can also find the antiderivative 1 minus 4x, but you cannot multiply them out to get the antiderivative for the product of those two functions. There is no such product rule here. Okay, the only rule is the linearity of the antiderivative. We just learned that. Right, so the only way you can solve the problem, you know, you can differentiate, right? Differentiate, you can apply product rule, but it's better to multiply this out, okay, to get polynomial. Then you find the antiderivative of each function. So it's going to be 1 over 3 plus 1 x to the 3 plus 1 minus 4, and the 4 plus 1 here, x to the 4 plus 1. Okay, that's simplified. Okay. Okay, very quick. And when you differentiate, you get the antiderivative of the original function. This is just a reverse procedure, you know, to find the you know the result, you want to find the recover the information. This technology used everywhere, right? Okay. This is where mathematics is used. Have you heard about anti-missile, right? System. Right? When the missile launched by an enemy, you get all the signals, data create, you know, he's flying, but it's flying all satisfying some equations, actually equations, but you don't know what kind of equations satisfy. But based on the data you collect, you have to quickly figure out the equations, lots of equations satisfying this by the missile in flying. It's only very few seconds, right? And based on that, you have to solve the inverse problem. Okay, once you get all the information quickly, the computer do very fast, but cannot do by human being. Okay, then you can predict what is the next step, right? Where it's flying. Then you can destroy it. You see, this is the way you have to. It's inverse problem, but I have to solve it quickly. Okay, so here you see a function is flying over to you. You know this is a derivative of some function. Can quickly find right the inverse, solve it. Right. All right. So let's do the next problem. Okay. Here's a function. Okay. It's going to be x plus 2 squared. Okay. So we want to find out capital Fx, the antiderivative. Yeah, the antiderivative of this function. Well, it's a power function, right? X plus 2 squared. I cannot do that directly, right? There's no other rules we can apply here. It's not like a derivative. We know that's general. We can use it to find the derivative of this function. But antiderivative is the inverse procedure. Find the antiderivative, you have to reverse this procedure. Okay, it's not easy. Yeah, it's much harder. Yeah, actually. So it's x squared plus 4x plus 4. Okay, then the antiderivative, you find the antiderivative of each of them. The first one is 1 over 2 plus 1, x to 2 plus 1, plus 4, and this is just 1, right? So 1 plus 1, x to 1 plus 1, and the 4 antiderivative is x. Okay. The reason 4 is 4x is because you can view it like x0, right? The antiderivative will be 0 plus 1, x 0 plus 1, so which is x. So when you differentiate, this is a 1 actually, right? So when you differentiate x, you get a 1. So the antiderivative of 1 is x. But you can also apply that formula to get this, okay? Because the power is 0. Right. So then you simplify it. This is antiderivative function. Similarly, if you give a function like this, how do we find the derivative? How do you find the antiderivative? So remember, how do we find the derivative? What is the best way to find the derivative? Well, there are still a number of students I see that if I put this problem on the quiz, they still use a quotient rule to find the derivative because it's presented like a quotient of two functions. But that's not the easiest way to do. Okay, you look at the function. This can be written as the sum of power functions. Find an antiderivative of this function, right? So it's the same idea. Yeah, if you can express it as a, you see, you can use a quotient to find the derivative, but right now we don't have any other method to find an antiderivative of such function quotient. Okay, so we cannot, we can do it later, but we cannot do it right now. It's a limited method. Okay, we are not able to find antiderivative of this function expressed as quotient of two functions. So we have to modify this function. It's 1 over square x plus x over square x, which is x to the negative 1/2 plus x to the 1/2. The sum of a power function. Then you can find an antiderivative because you can find antiderivatives of each of them. Okay. Okay, simplified, you get 2x to the 1/2 plus 2 over 3x to the 3 over 2. Okay, so that's it. When you double check, when you differentiate, you do get this original function back. Okay. find the antiderivative of the function here. It's going to be x to the 1/3, 1 minus x squared. Find an antiderivative of this f of x. Are you able to do that? Try this. Okay. For the same reason, it's a product of two functions. Even you want to find the derivative, the best way to do is multiply them out instead of applying the product rule to this function. Okay. So first of all, you express as a sum of two functions, sum of two power functions. So 1/3 plus 2, right? It's going to be 1/3 plus 2 is 7/3 here. Okay. And that's it, right? And then find the antiderivative of this function, not a derivative. Antiderivative is going to be 1/3 plus 1 here to the 1/3 plus 1 minus 7/3 plus 2, yeah? 7/3 plus 1. Okay. And then you simplify it. You get 3/4 x to the 4/3 minus 3/10 x to the 10/3. Yeah, 7/3 plus 1 is 10/3. All right, so let's do the next one. All right, if the function is given x plus pi/4, how to find the antiderivative? The couple ways to do. One is by guessing trying. Okay, I know what is antiderivative sine, negative cosine. Okay, I know the derivative of negative cosine x is going to be sine x. Okay, the derivative of sine x is going to be cosine x. So the antiderivative of cosine x is sine x, but antiderivative of sine x is negative cosine x. But how about sine pi/4? Right? We guess, right? But I guess it's probably going to be negative cosine x plus pi/4. Okay? The sine becomes negative cosine. Then you check. You know how to use the chain rule to find the derivative, right? Then check. Okay, first of all, guess. Make a guess, right? Then the derivative is going to be negative cosine becomes sine x plus pi/4. Then you differentiate x plus pi/4, you get a 1. Okay. So that is the answer. Okay. Now the derivative, if I modify the problem a little bit, if you differentiate negative cosine kx, you get sine kx and divide by k. So if you divide by k, then both sides equal, right? And the derivative of sine kx over k, you get cosine kx. So then you can get antiderivative of sine kx, which is negative cosine kx divided by k. Okay, question. Find an antiderivative of f of x, which is sine square x. The antiderivative of sine x is negative cosine x, but the sine square x is not going to be negative cosine square x. Okay, that's not such formula there. So you have to modify the function. I think it is going to be 1 minus cosine 2x divided by 2. Right? So it's linear combination, right? 1/2 cosine 2x. Then the antiderivative of this function is going to be antiderivative of 1/2. It's x over 2. And then what is the antiderivative of cosine 2x? It's going to be sine 2x, but you have to divide by 2. Right? So that's it. Okay, I'm going to ask you to do the next one. Find an antiderivative Well, secant square x, right? The antiderivative, just trying to figure out what derivative gives you this, right? And then we know that the derivative of tangent x is going to be, right? It's going to be 1 over cosine square x, which is secant square x. So the antiderivative is going to be tangent x. Next, we are going to find a very specific antiderivative, not just one antiderivative. Okay. For example, if capital Fx is going to be x squared minus 3x, but I know f capital 0 is 0, and that's going to 2. Find capital Fx. So you have to get a general formula first, then determine the coefficient, because if you just write down any antiderivative, probably does not match the given information. Okay, so you have to find all of them, then find the one particular antiderivative satisfying this initial condition. Okay, so first of all, write down the general antiderivative. Okay, it's going to be x squared. It's going to be 1 over 2 plus 1, x to the 2 plus 1, minus 3, 1 over 1 plus 1, and x to the 1 plus 1, and plus constant. If without constant, this is very special antiderivative. And when you plug 0 for x, you're not able to get 2. Okay. So the answer here is going to be 1/3 x cubed minus 3/2 x squared plus c. Then you determine the constant so that f of 0 is going to be 2. So it's going to be 0 plus c, which is going to be 2. That implies c is 2. So then my final answer is going to be 1/3 x cubed minus 3/2 x squared plus 2. We find this particular one. All right. So are you able to find this one? If the derivative is going to be 3 square x, and right, then find the capital F. Okay, you can try this. Find the most general antiderivative with the constant c. Then you determine the value of c so that f of 4 is going to be 25. Okay, so first you express this in the form like that, right? It's going to be 2 terms here, and the antiderivative of the first one will be just x. The second one will be 1 over 1/2 plus 1, x to the 1/2 plus 1, okay, and plus constant. So this is a general formula. It's going to be 3 over 2. So the answer will be x plus 2x 3 over 2 plus constant. Okay, so you get a general formula for all the antiderivative of this given function. But you're looking for the particular one, f of 4 equals 25. So f of 4 equals 4 plus 2 times 4 to the 3 over 2 plus constant, 4 plus 2. And how do you evaluate 4 to the 3 over 2? 4 to the 3 over 2 is 4 to the 1/2 first, and cube it. Right? It's the square root of 4 cubed. It's 2 cubed, right? It's 8. Right? So that answer will be 16 plus 4, 20. It's going to be 0. Not 0. It's 25, right? 25. So that implies C is going to be 5. Okay. And then you get the function, right? The function is going to be x plus 2, x to the 3 over 2 plus 5. So there is one particular antiderivative which satisfies the given initial data. Right? Now for practice, I really wish to, well, this is a little bit more complicated. So second derivative of the function is going to be this. So we are looking for, it's interesting. So this is the second derivative of the function. Okay, we're trying to find the original function. But we needed some initial condition here. Okay, so initial condition, when x equals 1, it's going to be 0. When f prime, it's going to be 8. This is a little bit new function. We have a derivative at work. Okay. So very first step, you see, the second derivative is going to the first derivative, then derivative, right? So so the first derivative is going to be the antiderivative of this function, 8x cubed plus 5. So it's going to be 8 over 4x to the fourth power and 1/4. No, that's just constant. Okay? And you have to put a constant again, very general form. Okay. The first derivative, the antiderivative of 8x cubed plus 5. Right. Maybe we can determine constant right now because we know the value of f1. Right? F prime 1 is going to be, it's 2 plus 5 plus c equals 8. So c is going to be 1. Okay, once you get c, then 2 to the x fourth power plus 5x plus 1. Right? Then you find the antiderivative of this function again. You get 2 over 4 plus 1 x to 4 plus 1. 5 is 1 plus 1 x to 1 plus 1. And here just x and plus another constant k. Okay. So it'll be 2 over 5 x to 5th. And here oh, yeah, you don't need to simplify. We just need to determine the constant c. All right, we know that. What do we got before, right? We got f of 1 equals 0. Well, that is going to be just k. F of 1, no, not 0. It's not 0. F1, not 0. Okay. F1. This have to simplify to 2 over 5 plus 5 over 2 plus 1 plus k. Okay. And that is supposed to be 0. And that is going to be 4 plus 25. It's 29. Okay. And that is going to be 29 over 2 plus 1, 31. Okay, so k equals negative 31/2. All right, so let's try and bring a new problem. The second derivative is going to be cosine x, okay? And I know f of 0 is 0, f of pi is going to be 1. Okay, find the f of x. Okay, are you able to do that? This is a 2n. It's not like it does not involve the derivative, but you need a condition, two variables, right? 0 at the pi, then you can determine, uniquely determine the function f of x. Okay, can you try this? Find the most general antiderivative. It was called constant. Okay. Then determine the constant using the given initial condition. All right. So let's try. Okay. First of all, you find the derivative. The is the antiderivative of the second derivative, right? The derivative is here is a derivative function is antiderivative of a cosine x. So which is going to be sine x plus constant when you differentiate the cosine x. That's the first. Okay. Then you're trying to find the antiderivative of sine x plus c. I cannot determine constant c, okay, using the given value. Maybe, okay. So sometimes you can, sometimes cannot. So we can keep going, okay, because there is no derivative. I don't know what is the derivative function of 0. So f of x should be equal to, how to get sine x? Negative cosine x, right? And how to get c? Cx. Then don't forget another constant k. Right? So this is the most general formula for the function satisfying that second order, called second order derivatives, differential equations. We call it differential equation. Yeah, just the so-called differential equations as the derivatives of some function satisfy a certain relationship. Okay, then that's called equation, differential equations. All right, so now you get the general solution. Once you get the general solution, then you determine the coefficient by the initial data. So f of 0 is going to be negative 1 plus 0 plus k, which is 0, right? And f of pi, cosine pi is negative, so it's positive, right? And plus c times pi plus k equals 1. Right? So from here, already get k equals 1. Then from here, k is 1, and so c is going to be negative 1 over pi. Okay? So you find this. Then you write down the formula. It's going to be negative cosine x minus x over pi and plus 1. Okay. So this is a function satisfying the equation. Now you have to try this next problem. The first derivative is going to be x plus 1 square x. And I also know that f of 1 equals 5. Find this function f of x. This is a differential equation. Right. You know the inverse, you know the derivative, the value, they find the original function. Okay, please do this problem. Problem number 34. All right, so you see that this is a quotient of two functions, x plus 1 divided by square x. you cannot easily find an antiderivative, no quotient rule you can use. So you have to express the sum of the power functions. The very first step. X divided by square x, just square x, and the 1 over square x. So it can be written as then you find the antiderivative. It's going to be 1 this is x to the negative 1 half plus 1. And don't forget, put a constant here. So get the most general formula. Okay, simplified. Okay. Then where's the initial condition? F of 1. F of 1 is 2 over 3 plus 2 plus c equals 5. So c is going to be 3 minus 2 over 3, 7 those. Okay. So the answer will be all right. So the next one is going to be f of x, the third derivative, not the second derivative, is going to be 1, identical 1. Okay. And we know that f of 0 is 1, f of prime 0 is going to be 2, and f double prime 0 is going to be 3, for example. Okay. So this is third order derivative. So to solve this problem, we do step by step, to get the original function f, which is expressed in the most general formula. Okay, most general form. So the second derivative, the derivative of second derivative is 1. So the second derivative will be x plus constant. Okay, maybe you can determine the constant right away because we are given the second derivative, right? The second derivative, it's 0 plus c equals 3. So that means c equals 3. Right? Right. Then you find the derivative of the function, which is 1/2 x squared plus 3x plus k. Okay, k is another constant. Then you look at the value, right? When x equals 0. When x equals 0, it's going to be 2, right? Which is k. So k should be equal to 2. So the function okay, so the derivative of the function is going to be given by this polynomial. Then you try to find the antiderivative, and then find each antiderivative of each term. Then you solve the problem. Okay, the antiderivative of x squared is 1/3 and this will be, let's use another one called d. Okay, so we get 1/6 x cubed plus 3/2 x squared plus 2x plus d. and f0 is 1. So when f0 is 1, that means when x is 0, the value is 1. That implies d should be equal to 1. So we solve the problem. Okay, we get the general formula. We get the formula for this is very special antiderivative. So antiderivative, so far we can find an antiderivative function of a linear combination of the power functions. Okay. I want you to do the following maximal optimization problems. Okay. So this is a isosceles triangle. Okay, it's 5, 5, 6. Okay. Find a rectangle inscribed inside the dimension, which has a maximal area. Find the rectangle, okay, of maximal area, okay, that is inscribed in the triangle as shown here. Okay, when h is at the bottom. Okay. Find the dimension, in other words, right? Then you can draw it. Dimension means give me the x and what is y. Okay. Yeah. Find x, y, and then you draw the triangle. This here you prove that this has the largest possible area. Definitely, right? If you make the rectangle more slim, vertical, then you shrink, you decrease the area. Okay? And if you push the top line lower, okay, then you also decrease the area, right? Collapse the one line at the bottom, and the area is 0. So when y approaches 0, the area is 0. When x approaches 0, area is 0. But x and y related. It's not like the independent variable. So the area is going to be just x times y, right? Okay, so let's do this problem. Geometry problem. If majority of you always have trouble to do this type of geometry problems, I will pass the message to the high school teachers whenever I have a chance. He says this is the type of problem students in college have to do. Supposedly in high school. Okay, find the relationship between x and y, right? Then you solve the problem. Yeah, what is the relationship between x and y? Okay, this is a nice isosceles triangle. And x can be, the largest possibility for x is 6. The smallest possibility for x is 0. So x is equal to 0. You have to express y in terms of x. You have to draw addition lines in order to figure out the relationship between X and Y. I'll give you 1 more minute to find the relationship between X and Y. All right, so now you can see. So the relationship between X and Y, all right, can be obtained from similar triangles. Okay, how do you look at similar triangle? One triangle is on the top. Okay, this is a x over 2, and the other side we don't know, right? Other side is the height is going to be 4 because 3, 4, 5. Everybody knows that, right? So this would be 4 minus y, and the other larger triangle is the 4 and the 3, right? Those two triangles similar. It's obvious. So the ratio of corresponding sides are equal. So that means 4 minus y over 4 equals half of x over 3. Okay. Then we're done. Okay. So get 3, 4 minus y equals 2x. Okay. 12 minus 3y equals 2x. And what is y? Right? Y is going to be 12 minus 2x divided by 3. So 4 minus 2 over 3x. Okay. So this is a y value. Okay. And so y cannot be when x equals 6, y is going to be 0. When x equals 0, y is going to be 4. So anyway, x is between 0 and 6. Okay. Then the corresponding y value is between 0, So the area is going to be x times y, x times 4 minus 2 over 3 of this. This is just a quadratic function. And you find the maximum value of this function, it's going to be 4x minus 2 over 3x squared and you differentiate, you get 4 minus 4 over 3x, and set to be 0. X is going to be 3. Okay, so when x equals 3, and you get y equals 2. Okay, because when x 3, y is 2, because 3 cancelled out. Yeah. So this triangle has largest area when x equals 3, half, and here must be 2. This triangle has a maximum area of among all the rectangles in square. Okay. Similarity triangles is required for this course, and the Pythagorean theory. It's just 2 basic geometric, geometric formulas, will be used in this chapter of optimization problems. Okay, and you have to, in geometry, you have to draw addition lines to find out similar triangles. They are not just given right away. Okay, like if you draw the vertical line, you say, oh, that's a 4. Then those are the very simple. There were the simple problems. When this is where I had to teach my child. So first of all, I asked him to figure out if walk 3 steps towards south, 4 steps to north, left, east. What is how many steps on diagonal? Then he figured out 5. Okay, I awarded him $1, but I said if we find another triangle, which was integer length, I can give him more awards. And he spent a couple days. Finally, he got another $2. Just find another triangle. And how many right triangle you remember, right? 5, 12, 13, right? Yeah, you have tried this. Draw many triangles. Find out. This is it's interesting. Okay, so see you next Monday. We're going to have another